Hello, good evening, everyone. Good evening. Give me a moment before start our lecture. Just check our audio. Hello. It's perfect. And start our class. Okay, guys. Good evening. So I welcome you all in Let's Crack JEE in English channel, and this is our lecture number 6 on permutation and combination. Okay. So we'll wait for a minute. I'll wait for people to come. Once everyone will be here, we'll start a session. Okay, so let's start our session. This is me. This is a small introduction about me. Hi, I am Nishant Khanduja. I graduated and post-graduated from IIT Bombay in 2014. I did my graduation and post-graduation in aerospace. My rank was 1256. AIEEE, my rank was 363. Rajasthan pre-engineering test, my rank was 4. I traded in US and Canadian markets for 2 years. I also have 8 years of experience. And I always wanted to teach students, those who are there from small cities. So this is something which is very close to my heart. It's like one of my goals, I can say. Right now I'm pursuing one of my goals in life, and all this happened all because of Unacademy. Why? Because I joined Unacademy and I got associated with them for their India's largest campaign, that is a Crack IIT JEE. And when I joined them for their largest campaign, I am doing my small bit by teaching you guys mathematics for JEE. Now, as you know, it's a two-way process. I can't only just teach till the time you guys are there to learn. So what do you need to do to learn from me? You need to install Unacademy Learning app. You install Unacademy Learning app from Play Store. You get two options. One is your Plus subscription, and another one is your Iconic subscription. So let's talk about Plus subscription. What all benefits you will be getting Plus subscription? We're going to attend daily live classes. So these daily live classes are completely different from YouTube live classes, because the kind of interaction you're going to have with the educator, that is better than YouTube classes. First of all, it is I would say that it is can be compared with YouTube at, because this is something different. You're going to chat with the educator, you're going to ask many questions, so it's like you'll be engaging the educator. It answers the polls which will be created by the educator. So in a way, the kind of experience you're going to have is next to offline classroom. You can also attempt live test and quizzes. So when you're going to attempt live test and quizzes, you can evaluate your preparation towards any topic. You can also courses. So let's say if you come to know that there is a teacher who is brilliant in organic chemistry and he's from Indore. So don't worry. This guy is there on an Unacademy platform with his structured courses. So what is the benefit of attending a structured courses? Because see, content is available on many online platforms. But when it comes to structured course, what it gives you? It gives you the maximum knowledge in time. And apart from that, you can also watch the recorded videos n number of times, wherever you feel like, whenever you feel like. You can watch these videos and you can revise the topic. So these are the benefits you get in Plus subscription. When it comes to Iconic subscription, apart from whatever benefits I spoke about, Plus subscription, you're going to have personal mentor. What is this personal mentor? So this personal mentor would be working with you for the next 1 year or maybe 2 years, depending upon your subscription. So this person, when I say he'll be working with you, what does that mean? That means he will be guiding you what to do, what not to do for the examination. He would ensure that you get better result. I would say the best result according to your own personality. Correct? Now, we also have test analysis report. This test analysis report would tell you where exactly you're losing marks, so in which topic, in which section, how you can improve the time management, how you can improve the examination approach. We also have study planner, so this study planner would customize the study according to your own needs. It would also review your progress. If at all it finds that there are any changes required to be made in your study plan, so those changes would be incorporated in next study plan. Okay, so this is what iconic subscription. So if I want to talk about iconic subscription in one word, I would say is goal oriented subscription. But it would make sure that you get best result. Now when it comes to buying the subscription, we have got 1, 3, 6, 12, 24 months. Let's say if a student is in 11th standard, I would suggest he must go for this 2 years package. And if he is there, if the student is there in 12th or maybe he's a dropper, then he must go for this 1 year subscription. Reasons are very simple. So let's talk about 11th student. So for him, the preparation is for 2 years. So he would love to have the access till the examination gets over, because at the end he would like to attempt mock test, he would like to revise. If at all this subscription gets over, he would not be able to access all these facilities, and that would risk his result. This should not happen. First. Second one is, all the courses are designed in such a manner that they are going to get completed into 2 years span, keeping enough time for each and every topic. Now, if your subscription gets over in between, so you would end up skipping a few topics, again you are risking your marks. So we are not going to do that at all. Third one is, it's very cost effective. Look at the price. Price is 2,303 rupees per month. If you look at per day wise, it is what, 78 rupees per day. If you look at per subject wise, it is what, 26 rupees per day per subject. It's very nominal. No, look at the price, 26 rupees per day per subject. Look, this is what you are going to pay. You just accumulate everything. What it is 56,000 rupees. And for 1 year subscription, it is 38,500 rupees. Now, when you apply this code NK001, the price would be reduced. It would become what? 34,650 rupees. And for 2 years, it would become 50,400 rupees. Now, I speak about iconic. For 2 years, it is 86,000 rupees. For 1 year, it is 56,000 rupees. But if you apply my code NK001, you are going to get 10% discount. And the price for 1 year subscription would become 50,400 rupees. And for 2 years, it would become 77,400. Now, if you ask any suggestion from me, I would suggest go for this subscription as soon as possible, because the reason is very simple. The more time you get for your preparation, the better result you get. Simple. You do not need to think about anything. Okay, so let's start our session. Hi Lalit. Hi Siddharth Yadav. How are you guys? Okay, so we are up for our session. Okay, cool. So I hope you must have revised everything about combinations, the restricted combination. We also solved a few questions yesterday. So today we'll be talking about distribution, division, circular permutation. So we'll be talking about all these things today. So let's start our session. Our session starts here. Circular distribution. So now, how you're going to solve this sort of problems? Just imagine you have got n objects, you can say n things, which are going to be arranged or distributed. They're going to be arranged in a circle, and they are going to be arranged in a circle. So how can you arrange them? So that's the question. So let me tell you one simplest way. Find out the number of ways you want to arrange n things in a circle. The best way is, it's all about from where you're going to start. What you can do is, you can first cut this. Can you cut this? So you will have what? How many places? You see, have how many places? You are going to have n places. Let's fix first one, and based on that, based on, you can fix one. Once you fix one, then how many places are left for you? Left with n minus 1 places. Now if you want to arrange things, so this place can be filled with what? N minus 1. This can be filled with n minus 2. This can be filled with what? N minus 3. Same thing here also. You can just block one and you have again n minus 1 places. So that's how you can easily just see circular arrangements. So how many ways you can arrange n objects in a circle? N minus 1 factorial. Clear? Is it clear with you guys? If the concept is clear with you guys, then we can move forward. If you want another explanation, I can give it to you. Siddharth, Lalit Kumar, what do you say? Okay. Let's move ahead then. I would like to share one more concept with you guys. Now tell me one thing, because this type of question, I have found people getting confused in this question a lot, regarding garland, regarding your garland questions, regarding your necklace question. So let me share an inside information with you. Thing is, see, whenever we try to arrange any objects, any n objects, we always look objects from one way. One way, what I mean to say is, so let's say if I'm looking these n objects, I'm looking them from out of the plane. I'm looking them from out of the plane, correct? True. Now, if you can see anything, any circular arrangement, if you can look at any circular arrangement from two ways. What I mean to say is, one way you can look at from out of the plane, like from here, the way we are facing the screen, and another way is if you can look at from the behind. Behind, what I mean to say is from inside the plane. If you can look at the circular arrangement from two directions, then the total number of arrangements are going to be what? N minus 1 factorial by 2. The reason is very simple. Just see, you look at something from here, something is arranged like this, let's say clockwise direction. Now the same thing, now one clockwise arrangement is different here, one clockwise, the same sort of arrangement, let's say in anti-clockwise you arranged. While you are calculating, see, from your, when you are looking it from the front, you are going to consider it two different variations. But when you look at from the back hand side, the same clockwise arrangement becomes anti-clockwise for you. So what I mean to say is, so basically your two types of arrangement, they become one. So that's why this divided by 2 is here. So the hint when to use by 2 or when not to use by 2, it's very simple. If you can look at the circular arrangement from both the ways, then use divided by 2, otherwise don't use divided by 2. Best example could be whenever we take table circular arrangements. So obviously you are going to see tables arrangement from one way, that means from top of the table. You're not going to see the arrangement below the table. Okay, so I hope you guys have understood when to use by two, when not to use two by two. Okay, if that is clear with you guys, then just give me a thumbs up. Then we'll move to the question. Okay, so what I need to say is how to identify when to use by two or when not to use, when to use by two, when not to use by two. It's very clear. So what I mean to say is if you can see any circular arrangement from two sides. So see garland, if I take garland's example, in garland's example, I can watch and I can see garlands from both the sides, from here as well as from behind also, right? Whereas if I talk about tables arrangement, I can only watch tables arrangement from the top of the table. I can't go below the table and see the arrangement. Are you getting it? So if you're having, and you can watch something. If I want to write it, so I'll write it like this. Then you can see circular arrangement both the sides. What I mean to say is both the sides, from the front and from the back. Then use half. Otherwise, you don't require half. Okay. I hope Siddharth, now you must have understood what I mean to say. In tables example, you can only watch the circular arrangement from the top, not from the below of the table. Cool. Let's move to the questions. See, look at the question. The question is, a person invites a group of 10 friends at dinner and sits. So a person, he has called 10 friends, fine, at dinner and sits. 5 on one round table and 5 more on another round table. So see, this is table number 1 and this is table number 2. Now this guy has invited a group of 10 friends. Hi Adya. So when he has invited a group of 10 friends, now he is going to make sure that 5 people sit here and 5 people sit here. So first of all, what he will do is, first he'll pick 5. So how can he pick 5? Yes, 10C5. That's how he can pick 5 friends. Okay, when he picks 5 friends, okay, let me tell you one thing. See, this is for the picking up. Let me share this information. See, if you are going to solve this question using division and distribution, so let me do that question using that division and distribution also, because I know many of you will get confused when I will be sharing division and distribution method also. So whenever we try to divide, see, there is one thing called division and the other one is called distribution. So when I want to divide this 10 friends group into 5 each, so the number of ways when I can divide, this is what? For the division. This is for the division. Now if I want to distribute, since there are 2 different tables, so when I want to distribute, for distribution I'll have to multiply with 2 factorial. This is for the distribution. Okay, which would turn out to be the same what is written up above. Okay, now I have got 5 people here, 5 people here. Now I want to arrange these 5 people. So how many ways are there? Obviously 4 factorial ways. Here also 4 factorial ways. So I am going to multiply with 4 factorial ways, 4 factorial ways. Similarly for this also, now I picked 5 people out of 10 people. Okay. I will be multiplying with 4 factorial into 4 factorial. Yes, absolutely right, Siddharth. Absolutely right. So this is the first number of ways. Now, for the B question. Now the question says 4 on one round table. So round table number 1. We have 4 people here. Now round table this 2. We are going to have 6 people here. Then we have to find the number of ways in each case in which he can arrange the guest. Now, first way to pick, let's say 4 people, the way he can pick 4 people will be what? 10 factorial divided by 4 factorial, 6 factorial. Okay. Now if you take from division also you'll get the same thing. From division also you get 10 factorial divided by 4 factorial, 6 factorial. Okay. So this is for the division. Now you want to distribute. Now if you want to distribute, you have to multiply with 2 factorial only. Okay. So now I'll explain you one more thing. So this is for division. Distribution, because you are going to distribute these 4 people and 6 people between 2 tables. For distribution it will be what? 10 factorial divided by 4 factorial, 6 factorial into 2 factorial. And then once 4 people are here, 6 people are here, so number of ways you can arrange them is 3 factorial, 5 factorial. 3 factorial into 5 of factorial. Okay, so this is the right way. Whereas in the book, because when I picked the question, I know many of you are going to consult with the book, but let me share this information with you guys. The solution in the book is absolutely wrong, because you can't consider both the tables same. These are 2 different tables. These are not same table. So this is for the picking up. This is only for the picking up. Once you picked up, now see 4 people can come to this place also, this place also. So you have to multiply with 2 factorial only. Then 3 factorial and then 5 factorial. This is the right answer for the number of ways by which you can arrange the guest. Siddharth, I hope you must have understood this. Siddharth, I hope you must have understood this question. Buddy, if you have any doubt, you can ask right now. Adya, what about Adya? Cool. It's very simple. What I have done is, I first picked, after picking up, I distributed between 2 tables. Let's move to our next question. So this question, find the number of ways in which 6 men and 5 women can dine at a round table if no 2 women are to sit together. 2 women can't sit together. So what do we need to do? So whenever we have this sort of constraint, we have also solved this sort of question earlier in normal arrangement, in normal permutation. We have solved this sort of question. Just hang on guys, before I move ahead. Siddharth is asking one doubt regarding the previous question. Siddharth says, sir, but division distribution के difference बोलिए. Okay, so division and distribution, there is a difference. I'll tell you. The difference is, see, if I come to know that I need to divide, let's say, these 3 different things. Okay, and let's say 2 will be together and 1 will be together. So how many ways are going to be there? So you will say, okay, 1 and 2 will make a group, then 3 will make a group, and 1 could be 1, 3 will make a group, then 2 will be here. Then you might say yes, 2, 3 will make a group, and 1 will be. So as you can see, there are 3 ways by you can divide. You are dividing it. You are not distributing it. Let me make it very clear with you. You are just dividing. You are dividing it. You are not distributing it. Now, when it comes to distribution, now let's say there is a guy called A and there is a guy called B. Now, tell me one thing. Now, when I'm distributing it, so 1, 2, this 1, 2 bag, it might go to A also and it can go to B also. So how many ways are there? See, one way would be that 1, 2 box will go to A and 3 will go to here. Another way could be when 3 will go here and 1, 2 will be here. So as you can see, when I'm distributing it, I have to multiply with 2 factorial. See, it's like you just made the selection, you made the division, selection. Now you want to distribute them. So you have to just multiply with number of persons available. I hope you must have understood. Do you understand this, Siddharth? Siddharth, did you understand the difference between division and distribution? Cool. So there is a difference between division and distribution. So this is your division. But don't worry, I am going to talk about this in today's class. Don't worry. So let's come back to the question. Question is, find the number of ways in which 6 men and 5 women can dine at a round table. No 2 women are to sit together. So it's again constraint arrangement. So when we have to make sure that 5 women can't sit together, so basically we have to make sure that these 5 women sit between men. So what I'm going to do first is, I'll make sure, let's place 6 men first. So when I'm placing men first, so I've got what? How many places? 6 places. 5 and this is your 6. So now 6 places are there for men. So I want to arrange. So how many ways I can arrange? 5 factorial ways. Cool. 5 factorial. Now once all the men they sat, suppose that how many places are there between any 2 men? See, 1, 2, 3, 4, 5, 6. So out of these 6 places, I can pick, let's say, 5 places where I'll ask women to sit. So that obviously women are not going to be sit together. So what I'll do is, out of these 6 places, I'll just pick 5 places for women. Once I pick 5 places, I'll just ask them to sit. So how many ways I can arrange them? 5 factorial ways. If I solve it further, what do I get? 5 factorial into 5 factorial and into what? 6. So this is what? 120 square. This is your final answer. Hope this is also clear with you guys. Cool. If this is clear with you guys, just give me a thumbs up. Siddharth, Adya, Lalit. Let's move to the next question. Okay. Siddharth, try understanding this question. The question says, find the number of ways in which 8 different flowers can be strung to form a garland so that 4 particular flowers are never separated. So there is a constraint as well as the garland question. So when it's a garland question, so that means garland can be seen from the front as well as from the back. Okay, so let's talk about the total number of ways. What it says, what is the question? Find the number of ways where 8 different flowers, out of 8 different flowers, 4 flowers are going to be together. That means basically how many objects are there with us? 1 flower, 2 flower, 3 flower, 4 flower. These are together. We have 5th class, 6th class, 7th class, 8th class. So basically we have got 5 objects. So if I want to arrange these 5 objects in a circle, how many ways will be there? And it's a garland. It's a garland. So as you can see, we have 5 objects. So 5 minus 1 factorial divided by what? 2, since it's a garland, into. Now this is the arrangement. Now these 4 people, this 4 class, they can also swipe places among each other. That means if I want to arrange these flowers, 4 flowers, so I have to write 4 factorial. So that's it. Yes, Siddharth, buy 2 wala funda. Absolutely right. Hi Mithilesh Sharma, how are you? So let's move to our next question. The question says, find the number of ways in which 6 persons can be seated at a round table so that all shall not have the same neighbors in any 2 arrangements. Let's read the question. I'm good, Mithilesh. What about you? Hope you learned something in today's class. So let's read the question. What question says? Question says we have to arrange. So 6 people are there and sitting on the round table, and we have to 1, 2, 3, 4, 5, 6. These are the 6 people, and I have to arrange their sitting arrangement in such a manner that all means all 6 shall not have the same neighbors in any 2 arrangements. So now try to understand this question. What it says, shall not have the same neighbors. So obviously, now tell me one thing. What sort of cases will be there when we'll have same neighbors in any 2 arrangements? The only way is, let's say if my guy number 1 is sitting, 1 is sitting here, 2 is sitting next to 1, then 3, 4, 5. They're sitting like this. So this is one way. So where 5 is next to 6 and 5 is next to 4 as well. What could be the other arrangement when we'll have exactly the same neighbors for all? Other case would be like this: 1, 2, 3, 4, 5 and 6. Now again see, 5 is sitting next to 4 and 5. So basically, as you can see, if this is anti-clockwise, then for clockwise also we'll have the same neighbors. So we have to consider only one. Apart from these 2, I have to consider, or you can say I have to count only one case. So exactly, see, clockwise, anti-clockwise, for the same neighbors, we are going to have 2 arrangements. So first let's find out how many total number of cases. So 6 minus 1 factorial, so 5 factorial, that will give you 120. So in these 120, for one set of neighbors, so one set of neighbors for all, we have 2 sort of arrangements, clockwise and anti-clockwise. Cool. So if I want to count only one, so what I have to do, I have to divide by 2. So out of clockwise and anti-clockwise, arrangements, I have to pick only one. So in that case, it will be what, 120 by 2 becomes 60. 60 will be your answer. Siddharth, Mithilesh, Lalit. Did you guys understand the question? If you have understood it, just give me a thumbs up. Give me a thumbs up, guys. Okay, let's move to our next concept. All possible selection from distinct objects. So when it says all possible, so all possible means what? Let's say I have got n things or n objects. So when it says all possible selection means from n things I can choose 0 things. I can also pick 1 thing. I can pick 2 things. I can pick 3 things. Similarly, I can pick what? N. So these are the possible cases, right? So when I pick 0 people, so all these are what? Either ways. So 0 pick up, 1 picked up, 2 pick up, when you're picking 2 things up, okay? Similarly for n things also. All these cases are what? Mutually exclusive. So if I want to calculate the total number of ways, I have to add them up. So now let's say, tell me one thing. If I want to pick 0 things from n things, how many ways will be there? So nc0. For 1, it will be what? nc1. 2 what? nc2. And it will keep continuing till nc, right? And what it is, if people remember your binomial theorem, you would say it is what? 2 raised to. Now, I'll tell you the second approach also, and the second approach I really like the most because that is very intuitive approach. This is your approach number 1. If I talk about approach number 2, so how can I pick? So it's like I have got n things. So I'll let it like this. Let's say first object, second object, third object. Thank you, Mithilesh. This is nth object. Okay. Now, like now I want to select out of these n distinct things. I want to select. So I'll go to first object. So first object has 2 ways to be selected. Either it will say yes or no. Yes or no. Similarly for second also yes or no. So how many ways I can select first? 2 ways, yes or no. Similarly for this also second, yes or no. For third also 2 ways. Till end 2 ways. Now everything is happening what? Simultaneously. So it will be what? 2 into 2 into 2. Finally it will be what? 2 raised to. Okay. Now if someone comes to you and says, in this, as you can see, even in your first approach also, as you can see, I have taken the case where I am picking 0 object. Now if someone comes and says that I want to know the total number of ways of selecting n things where I am going to choose at least 1 object. So in that case, I have to just skip this. And I want to skip this, so I'll have to put what? -1. It will be what? nc1, nc2, and it will keep continue what? Till nc3 or 2 raised to n. I'm picking at least 1. From here also, just imagine if no, for every object, if you're getting no, that one case is also being counted here. Okay, so if you want to exclude that case, you have to put what? -1. At least one selection. So you have what? 2 and -1. I hope you must have understood. Is this thing clear with everyone? Siddharth, Dalit, Mithilesh, and we also have Adya. Is this clear with you guys? Okay, perfect. Let's go to our next thing. Now the thing is, earlier we were talking about different objects. Different. Now Their thing is what? All possible selections are from alike objects, like basically same object, similar objects, same objects. Now tell me one thing. Now let's say if I've got same 5 things. So how many ways are there from all the possible selection? Possible selection is all possible. That means I can pick 0 things, I can pick 1 thing, I can pick 2 things, I can pick 3 things, I can pick 4 things, I can pick 5 things. So how many ways are there? 1, 2, 3, 4, 5, 6. Because everything is what? Alike, same. So how many ways are there? 6 ways. Similarly, if you take n things, you get what? You get what? N plus 1 ways for the all possible selection. If again someone comes and says at least one object should be there, so basically you are going to exclude this case, 0 case. At least one selection, that means you'll have only n ways. I hope this is clear with everyone. Krish says, I have also taken NK001. It's good, I think you should also take it. What have you taken NK001? I didn't get, Mithilesh, what are you trying to say? This is my code, NK001. You can apply it when you are about to buy Plus or Iconic subscription. Okay. This is what? This is for at least one selection. I hope this is clear with you guys. Start. Great. Now let's talk about number of divisors of n. Now let's say there is a number n. Now tell me one thing, any number can be written in terms of prime numbers. Right? You can write any number in terms of prime numbers. True? For say, for an example, there is number n can be written in terms of, let's say, 2 raised to p, 3 raised to q, 5 raised to r, 7 raised to something, let's say t, and all the possible prime numbers. That's all up to you guys. So let's say right now I'm taking, let's say, only this specific case. Okay. Now someone comes and says, tell me the number of possible divisors. See, possible divisors would be what? Any number which is having what? Power of 3, some power of 3, some power of 3, some power of 2, some power of 3, some power of, I'll write, let's say x1, x2, 5, 3, 7, x4, like this, right? Thank you, Mithilesh. Thanks a lot. Okay, so let's talk about this possible divisors. So any number will be like this, right? Any divisor. So this x1, x2, now tell me one thing. This x1 can take value from 0 to p, yes or no? Right? It will take value in integer term, but from 0 to p, right? So basically it's like 2 is getting multiplied. It's like number of 2's you are picking from p objects. From p objects you are picking what? Number of 2's. So how many possible cases are there? Obviously for picking up 2's you will say p plus 1 ways. For 3 also you will say what? q plus 1 ways. 5 also you will say what? R plus 1 ways. For 7 also you will say t plus 1 ways. Like this. Here. So when you see, so this is what? This will give you what? Total number of possible divisors. Now, Obviously these ways, or I can say total number of divisors. These total number of divisors, they have n, the number, and 1, because 1 is also like a divisor, right? Because if you are taking 2's exponent 0, 3's exponent 0, 5 exponent 0, 7 exponent 0, so you get what? 1 only. So it includes n and 1. So this is what? Inclusive. Now if you want to extract, what you will do? So total number of ways minus 2. Do what? Total number of ways minus 2. Including n and 1. Cool. I hope this is clear with everyone. Okay. Now this, when you exclude n and 1, these number of divisors, these divisors are called proper divisors. We call them what? Proper divisors. So divisors which are not including n and 1, they are called proper divisors. I hope this is clear with everyone. Okay. One more thing I would like to share this with you guys. Generally we get this sort of questions also. Some of the divisors, some of all the divisors. So when you want to calculate the sum, so that summation is basically, see, so just to explain you guys, when you are summing something up, let's say is what? 2 raised to 0, 3 raised to 0, then 5 raised to 0, 7 raised to 0. Similarly, you will have what? 2 raised to 1, 3 raised to 0, 5 raised to 0, then 7 raised to 0. It will keep continuing till your 2 reaches its maximum power, what? P. Right? Now let's say you fix 2, 5 and 7. Now your 3 will start varying, 3 raised to 1, and again it will keep continuing till 3's power. So then 2, 0, 3p, 5, 0, 7, 0. So similarly, every term will have its own variation. So if you want, if you ask me, if I want to just write it in on a specific manner, or I would say simplified manner, so I would be seeing it like this: 2 raised to 0 plus 2 raised to 1, and it will keep continuing till 2 raised to p. Because in that case, I will take 3 raised to 0, 5 raised to 0, and 7 raised to 0 as common. With other terms also, I will be taking that common. And for p or for 3 also, it will be the same thing. And this will be what? 3 raised to q. 5 raised to 0, 5 raised to 1, and it will keep continuing till what? 5 raised to r. For 7 also, it will be the same. Okay. Now, this is the summation. Now, can you see that every term, it looks like as if they are GP, right? So, what is the summation of GP? The first summation will be what? See, as you can see, the first term is A is what? 1 here. And your common ratio is what? 2. So, how many terms are there? So, see, as you can see, these are P terms, and this is what? P plus 1. So, P plus 1 terms are there, minus 1 upon 2 minus 1 here. Similarly, for 3 also, again, 3 raised to q plus 1 minus 1 upon 3 minus 1, 2. 5 raised to r plus 1 minus 1 upon 5 minus 1. So see, I am doing one specific case for you where we have when we factorize n, we get only 2, 3, 5, 7 as prime numbers. You might have different case also. So you can just understand the process, because process is important. So like this. So this is the summation of all the divisors, and it includes n and 1. N and 1 is also included. in the summation. Okay, so remember this. This is very important aspect. What Mithilesh says, bro, it is the best. I was also in a coaching. I left it last week and took subscription and got discounts by applying sir's code. My friend told me about it. Thanks a lot, Mithilesh. Thanks a lot. And yes, I know it's beneficial, and I keep saying to everyone that it's beneficial for your preparation. Siddharth, Mithilesh, Lalit Kumar, Adya, I hope till here everything is clear with everyone. If it is clear, just show me a thumbs up. Show me a thumbs up. Cool, Mithilesh. Okay, so let's move to question. Yes, Siddharth. Siddharth, Mithilesh, Lalit, Adya, and whosoever is there in the class, I would request you guys to solve this question. Read the question. Question says there are 5 historical monuments, 6 gardens, 7 shopping malls in a city. In how many ways a tourist can visit the city if he visits at least one shopping mall? See, it's about visiting. It's about visiting. It's not about which thing is visited first. It's about visiting. So it's like you just need to make selection. So let's do the question. Siddharth, try the question and tell me the answer. And for others also, I would request you also attempt the question. There is no answer from anyone. It's okay. I'll tell you. See, this guy has got 5 historical monuments. See, obviously historical monuments. So obviously historical monuments are going to be different. They're not alike objects. They're not same, right? 6 gardens are also different. 7 shopping malls are also different. Now, so what he'll do is, let's say he'll have 5 monuments. One of first monument, second, third one, fourth one, and let's say the 5th. He'll go to each monument and ask the question, yes, no, yes, no, yes, no, right? Because he need to make a selection, all possible selection. So he'll go and he'll ask. So he'll have what? 2 raised to 5 ways. Similarly for gardens also 2 raised to 6. But for shopping malls, as the condition says, he visits at least one shopping mall. So we have to exclude that 0 case. 2 raised to 7 minus 1. That's it. The answer is what? 2 raised to 13. 2 raised to 7 minus 1. Because the condition says is he visits at least one shopping mall. Condition never says that he visits at least one place. Had it been one place out of 5 historical, 6 gardens and 7 shopping malls, the answer would have been, if the question asked at least one place out of gardens, monuments and malls. Then the answer would have been, so we have 5 monuments, then 6 gardens, 7 shopping malls. So he'll go to everyone and ask the question, yes, no, yes, no, yes, no. So 2 raised to what? 18 minus 1. Then the answer would have been like this. I hope you guys have understood this question. Siddharth, I expected you to solve this question. Why aren't you solving question today? What happened with you? Were you not able to crack the question, or it just it was difficult? Yes, Siddharth? Siddharth? There's no response from Siddharth, so let's move ahead. The question is, next question is, there are 3 books of mathematics, 4 of science, 5 of literature. So again, see, there are books. So obviously books can't be alike. It's not said. That means again different books. Different books, different books, and different books. How many different collections can be made such that each collection consists of 1 book of each subject? 1 book of each subject. So now it needs to make collection, and each collection has 1 book of each subject. Only 1 book in the collection, only 1 book is there from mathematics, science and literature. So how many ways? So in that case, we'll have what? 3C1 into what? 4C1 into what? 5C1. Okay. What will be the answer? 3 into 4 into 5. So it's like I'm picking 1 book out of 3 mathematics book. I'm picking 1 science book out of 4. I'm picking one literature book out of 5. What will be the answer? 20 into 3. 60 ways. Here. Now let's take this case. At least 1 book of each subject. 1 book of each subject. So in that case, what will happen? So again, there are 3 different books of mathematics. So I'll go to every book. Let's say this is math 1, math 2, math 3. I'll ask yes, no, yes, no. So it will be what? 2 raised to 3 minus 1. Similarly for science also 2 raised to 4 minus 1. For literature also 2 raised to 5 minus 1. It says what? At least 1 book of each subject. If you want to solve it other way around, I'll also share the other approach also. So this will be what? This will be what? 7 into 15 to what? 31. Correct, Siddharth. Absolutely right. If you want to solve it the other way around, so you will say what? At least 1 book of maths. So you will say 3C1, 3C2, 3C3. Similarly for science also 4C1 till 4C4. For literature also 5C1 till 5C5. I hope this is clear with everyone. Okay, so this will also give you the same answer. Now let's talk about this third case. When it says at least 1 book of literature, it says what? At least in the selection we should have what? We should have at least 1 book of literature. Other cases are open. Mathematics can have any books. Science can have any book. So what does that mean? When mathematics can have any book, so that means 2 raised to 3. Science, for science also it will be what? Any book. This But for literature, it will be what? 2 raised to 5 minus 1. Basically what? 8 into 16 into what? 31. Yes, Siddharth, absolutely right. Very good, Siddharth. Very good. Correct. Now let's move to our next question. This is the question. Let's read the question. The question says, find the total number of proper factors. Proper factors basically divisors. Okay. Find the number of proper divisors. So proper means what? Excluding n and 1. N basically the number. N and 1. Find the total number of proper factors of the number this. Okay guys, let's do this. First do this. Siddharth says 3968. Let's see the answer. So let's factorize this 35700 first. When we try to factorize this, so what I'll do is, because I can take 100 for sure, I can remove 100. So 100 will be what? It is basically 10 square. 10 square is basically what? 2 square into 5 square, right? I can write it like this. So now let's find out the factors of this. Okay, Siddharth says 3968 is the answer for this question. Okay, Siddharth. No issues. Okay, so if you want to solve this question, then you solve. I wait for you. Then I'll solve the question. I give this question to others also. I would request everyone to solve this question. Okay, Siddharth. No issues. No issues. Come on, guys. Let's see what Siddharth says. So if you want to break 357, so you can try it with 3. If you try with 3, so you have what? You have 1, then you have what? 1 again, 27, 9. This can be divided with what? This can be divided with 7 if you want to try it. 7, yes, we can try 7. That will be what? 1, 49, 49, 49. Again, 7. Then again, we can use 17. So if I want to see the factors of this number, so this will be what? 2 raised to 2, 5 raised to 2, 3, we have 7, and we have 11. We have 17. Okay. Now, it says find the total number of proper factors. Proper factors. First, calculate the all possible factors. So all possible factors will be what? 3, then again 3, 2, 2, then again 2. And I'll the possible factors. So 9 into this 9 into 8, 72. Okay, Siddharth, all possible factors are 72. 9 into 8. But when we take proper factors, so we have to exclude 1 and n also as factors, because 1 can also come. So we have to exclude. So proper factors. -72 minus 2, 70. Clear? Is this part clear with you, Siddharth? Is this part clear with you? Siddharth, if this is clear, then shall I move ahead? Siddharth, give me a thumbs up if this is clear with you. Seems Siddharth is not there. What about others? Lalit, Adya, Mitlesh. Okay, let's move ahead then. Why two threes and three? Why two threes? And that says sir, why two threes and three twos? Okay, I guess you forgot the concept. See, these are alike. These are alike, right? These so possible options. If I want to pick, if I want to pick two, or if I want to select two, what are the possible options? I can have two zero twos, zero twos. I can have one two. I can have two twos, right? So how many ways? Three ways for two. Similarly for 5 also 3 ways. For 3 I have 0 3 option and I have 1 3 option. So these are the two ways. Okay. So this is what I meant. Hope this is clear with you. If this is clear with you, then yes, give me a thumbs up. Now, if this is clear with you, just give me a thumbs up. Perfect. So sum of, okay, so now this is done. So proper factor is done. Let's solve question number A. Siddharth, solve question number A. I just explained the derivation or the process to find the sum of all these factors. Tell me, how would you solve this? You can share the process also. Do we have other people also in the class? Now, how would we solve this? Sum of all these proper factors. All these proper factors. So let's do one thing. First, find out the summation of all these factors, and we'll subtract 1 and n. So when I find the summation of all the possible factors, sum of all the possible factors, this will be what? If you remember, we'll have we'll have a GP starting from 2. So 2 raised to 0, 2 raised to 1, then 2, 5 also, 5 raised to 0, 5 raised to 1, plus 5 raised to 2. Then for 3 also 3 raised to 0, 3. For 7 also 7 raised to 0, 7. And for 17 also 7 raised to 3 raised to 0 plus 17. Let's find the summation here. So this is what? This is 4 plus 2, 6, 6, 7 into 25, 25, 5, 15, 25 plus 5, 30, 30 plus 1, 31 into 3, 1, 4, 7, 1, 8, 17 plus 1, 18. This will be your summation. So let's find out the summation using the calculator here. Those who have solved the question, you can just tell me the answer though. So the put 7, 2, 6, 6. 8. So guys, you can also do the summation because I think I made a calculation mistake while multiplying this. This is what I'm getting. One, 2, 4, 9, 9. This is what I'm getting. Now, you can reduce if you want to calculate the proper factor summation. Proper factors summation. What do I need to do? I need to subtract what? 1, 2, 4, 9, and 2, and this. I need to subtract from this. I have to subtract 1 and 3, 5, 7. What will be the answer? -1 minus 3, 5, 7, 8, 9, 2, 9, 1. So this is what I'll get. So you guys can also cross check it. Yes, Siddharth, absolutely right. Now let's do one thing. Let's solve this case, this specific case. Some of the odd, what it says, odd proper divisors. So we have to pick only odd proper divisors. So I would request Siddharth and other people to solve this part also. Then tell me the answer. Then tell me the answer. Come on, Siddharth. Okay. So what does that mean? When I say sum of odd proper divisors, that means there should not be any 2's term. Any 2's term in the divisors, right? That means, okay, let's see. Let's check the answer, Siddharth, then. Comes out to be what? 5, 0 plus 5, 1 plus 5 square. So basically, apart from this term, you have to write everything. So shall I do one thing? I'll directly write it here. 31 into 4 into 8 to 18. So when I sum it up, I get what? 31 into 4 into 8 to 18. So I get this 17, 8, 5, 6. Now let's just look at this. Very good thing here. So these are what? This is inclusive what? This is inclusive all the divisors. All these divisors matlab, that means inclusive 1, not n. Why n is not inclusive? Because n is what? Even. So if you want to find out the summation, you have to subtract 1. The sum of all the odd proper divisors. Odd proper divisor summation. 17, 8, 5. So this will be your answer. Yeah. Yeah, Siddharth, absolutely right. You can divide 7 also. Absolutely right. That works. But you have to subtract from 1 also. Because this is what? The summation what we have got. This is inclusive of your improper divisors, n and 1. But you can't subtract n here because n is even. And you have calculated the summation of odd divisors. Now let's calculate the C part. Let's solve C part, Siddharth, where we have to find the number of proper divisors first. Proper divisors divisible by 10. and the sum of these divisors, and then you have to calculate the summation of these divisors. Siddharth and whosoever is there in the class, I would request you to attempt this question also. Come on, Siddharth. Siddharth says 214. Let's check, Siddharth. The number of proper divisors divisible by 10. Divisible by 10. So let's see any number which want to be divided by which is going to be divided by 10. That means that should have at least 1, 2 and 1, 5 at least, correct? That means if I want to pick, so how many ways I can pick 2? I can pick 2 in 2 ways. Similarly 5 also I can pick 2 ways, and rest numbers I can pick as it is. Okay, what will be the answer? So this will be what? 2 raised to 5. 2 raised to 5 will be what? 32. Now in this 32, now tell me one thing. Do you have n or 1? Obviously you have n, not 1. So exclude that 1. So if you will exclude that 1, so the proper divisors would be what? 31, which are divisible by 10. Is this clear with you guys? I hope this is clear with everyone. Siddharth, can you please tell me how did we get 214? Siddharth, can you please share me how did we get 214? Siddharth here. Siddharth, can you please tell me how did you get 214? तुमने 2 और 5 का केस ले लिया. What does that mean? समझाओगे थोड़ा सा क्या किया तुमने exactly? What I understand is the number should be divisible by 10. That means it should have at least 1, 2 and 1, 5. This is what I understand. So I just incorporated that condition. Simple. I excluded that 1 wala condition. That's it. So it's like when I picked 2. So out of 2, I picked what? At least 1, 2, at least 5, at least 1, 5, then 3, 7, anything, any possible option from there. Clear? Oh, 5 into 2, no sir. It's okay. Now let's calculate the summation. Sum of these divisors. When you want to calculate the summation, so in summation what will happen? So in summation, obviously, you're not, when you start the summation, so this summation would start from here, 2 raised to 1, 2 raised to 2, 5 raised to 1, 5 raised to 2. And again the same thing, 3 raised to 0 plus 3, 7 raised to 0 plus 7, then 17 raised to 0 plus 17. So the final answer will be what? This is 6, 30, 630. We'll have 4, 8, then 18. Let's use calculator. 180, 8, 4, 2, 8. This is the summation. What? 10368. So this is the summation. Now from these summation, obviously this has got n also in the summation. We have to exclude n summation because we have to find the summation of only proper divisors. So you'll have to subtract this 35700. Let's subtract this. Final answer will be what? 6798 will be your final answer. That, hope you got the question. That, did you get the question? Shall we move to the next question then? Cool. So let's talk about our concept. Let's talk about the next concept. What is this concept? First, this concept is distribution of distinct objects. Okay. What it says, distribution. It is not division. So to distribute anything, first you have to divide, then only we can distribute. So we have got distinct objects, different objects. So when it is divided into unequal groups means, let's say n fact, you have n things, and these n things are, let's say, divided into two groups. So obviously if you are picking, let's say, r thing, so other will be what? N minus r. And since it is clearly said that n minus r is not going to be equal to r. Why? Because we are making unequal groups. So the total number of ways will be what? N factorial divided by n minus r factorial on r factorial. This is for two groups. If you want to go ahead with, let's say, more groups, you can take, let's say, right now I'll take three groups. N things were divided into, let's say, m things, p things, and r things. And obviously m plus p plus r is what? N. For this. So your n factorial upon m factorial, p factorial, and r factorial. So see, this is what? This is only for division. This is only for division. Now, if let's say you want to distribute these two groups into two people or two person, you have to multiply with 2 factorial. Then this entire thing becomes distribution. Hope this is clear with everyone. This is again division. The moment you start distributing these three groups among three people, three persons, or three objects, whatever it is, you have to multiply with 3 factorial. This becomes what? Distribution. Okay, is it clear? Now, when you try dividing this into equal parts, again different objects, n things are there, and let's say you want to divide this into 2 parts, by 2 n by 2. What will happen is, total number of ways you can divide, that will be what? N by 2 factorial by 2 divided by 2 factorial. So the number of same groups, so this factorial is always like number of same groups. So this is for division. But if you want to distribute among between two people, then you have to multiply with 2 factorials for distribution. Similarly, if you have got what 3 groups, say n by 3, n by 3, by 3. The total number of ways you can divide this is for the division. For distribution, you have to multiply with 3 factorial. Is this clear with everyone? For distribution, okay. So I hope this is also clear with you guys. Cool. Perfect. Let's move to our next concept. The concept is when you have to distribution of n distinct objects. Okay, but this time you are distributing these n distinct objects in r different boxes, given any objects, any number of objects can be placed in any box. So what I mean to say is, you have got r boxes like this. Okay. Now these are r boxes. Now I have got n different things. If I want to calculate the total number of ways, how will I start? Very easy. So I'll take the, let's say, first object. First object would come and it would say, I can go in any box. So how many options are there? It will say R options, R. For second also, again R. For third object also R. So it will keep continuing till n. So basically we have R is to n. So this is for R is to n, when any number of objects can be placed in any box. Here, when empty boxes is not allowed. When empty boxes is not allowed, what does that mean? That means every box should have different, at least one different objects. At least one different objects. What I'm going to say is, at least, let's say 1 here, 2 could be here, 3 could be here, and obviously other numbers also, other numbers also, other numbers also, other number also. Again R boxes. Tell me, how would you approach this process? Siddharth, are you there in the class? Tell me, how would you approach this question? So again, let's say I have got n different things. So what I'll do is, first I'll calculate the total number of ways I can just distribute these n different things in R boxes. R is to n. If I can subtract when boxes were empty, what I can do is I can pick when one box was empty, when two boxes were empty, when three boxes were empty, when four boxes were empty, right? So let's take when one box was empty. What I'll do is, first I'll pick one box. Out of R box, I'm going to pick one box. I picked one box. When I picked one box, now how many options are there for n different things? For first object, I have got what? R minus 1, because I have to keep one box empty. So again, R minus 1 to keep until n. See, tell me this one thing. When I'm calculating this option will have those cases also when two boxes were empty, right? So let's reduce that also. Let's subtract that, because right now I have to subtract when boxes are empty. But in this case, I have calculated when any box. to be empty. So what I'll be doing, I'll be writing here RC2 R minus 2 and then again plus. So it will keep continue and we'll have last term like this minus this 2 R have last RC or then final we have 1 also. Here this is your R minus 1, right? So it will keep continue and R minus 1. So R minus 1 we'll have 1 here. So let's say R minus. This will become your RCR. RC R minus 1 plus. Okay. So you can just open the bracket and we'll get your answer. So this is the specific case when empty boxes, not when any empty box is not allowed. Clear? Let's move to our next concept. Siddharth, is everything clear with you? Now let's talk about the distribution of identical objects. Identical means same. So how do we do this? So the very first way is when are different boxes, if any number of objects can be placed in any box. So how can we do that? Very simple. So what do we do this? We assume, let's say, same boxes are like this. Same objects are like this. So now let's say these are n boxes, n things, same things, n same things. Now if I want to distribute this into among r different boxes, what I do is I introduce the bars, r minus 1 bars. These are what? Basically r minus 1 bars. Again same bars. So whenever these bars are placed, so whatever is left to one bar will be given to box number 1. So bar 2, left to bar 2 is, this will be given to what? Box. So that's how many cases will be there? How many boxes? So how many parts will create? We will create R parts. How? You can take, let's say, this example. Say I have these many things. I want to distribute these things in 3 parts. So what I'll do is, instead of 3, I'll be incorporating only 2 bars. This. So as you can see, this is your 1 part, this is the second part, and this is your 3rd part. That's how introducing 2 bars will break this into 3 parts. Clear? I hope this is clear, Siddharth. Is this clear, Siddharth? So now, how are we going to arrange this? So to arrange this, tell me one thing. How many total objects are there? So I have got n things, plus I have got also r minus 1 bars. I have to arrange all of them. Let's arrange all of them. But I have got same things also. How many same things are there? That it says identical objects, so n factorial. Here I have also got what? R minus 1 objects. They are also saying R minus 1. Is it clear? Is it clear with you guys? If you have understood this concept, then give me a thumbs up. Give me a thumbs up, guys. If this is clear with you guys. Okay. Whosoever is there in the class, Siddharth, Mithilesh, Ekta, Lalit Kumar, Adya. Okay, let's move to our next concept. The concept is when empty box is not allowed. An empty box is not allowed. What does that mean? That means, let's say we have n things. We have got what r boxes. What we'll do is, first we'll give one object, but this is the constraint. We'll give one object to every single object, to every single box. So how many things are left with us? So I'm left with n minus r things left. So now I have to only distribute these n minus r things among r things, right? N minus r things I have to distribute among r boxes. So to distribute among r boxes, how many bars I have to introduce? R minus 1 bars. So let's talk about total objects. Total objects for the arrangements. We have n minus r plus r minus 1. Actually n minus 1. Total arrangements. We have n minus 1 factorial upon how many same objects are there? R minus 1 bars and bars. Here. Hope this is clear with everyone. It's very simple. So whatever comes to the left of the bar, we just give it to the designated box. So left to the first bar, it goes to box number 1. Box number 2, then box number 3. That's how we do it. Clear? Okay. Let's move to our one more concept. Now, distribution of identical objects. Application. What could be the application we can? First question is, are different boxes, any number of objects are placed in the box. So what are sort of questions, applications we can get? We can have linear equations. This we can have linear equations solve. So when it says any number, that means non-negative solution. Types questions. When empty box is not allowed, that means positive solution for linear. For linear equation. When I say linear equation, so what I mean to say is like this: x1, x2, x3. Basically, every variable is having the same weightage. Same weightage. This is the limitation of this concept. Okay, so let's see some questions. I hope then you will be you will be able to understand it in a better manner. Non-negative integral solutions, this positive integral solutions. Spoke about it. Now let's solve this question. The question is, there are 2m white counters. There have got what? 2m white counters, 2 red counters, and they are arranged in a straight line. Okay, so arranging 2m white and 2m red, and see, these are alike, these are also alike. Same. Arranged in a straight line with m plus n counters on each side of a central mark. Okay, so there is, let's say, central mark. So total is what? m plus 2n. Out of these 2m plus 2n, m plus n are here, and remaining m plus n are here. The number of ways of arranging the counters so that the arrangements are symmetrical, okay, with respect to the central mark. Okay, tell me, how will you solve this question? It's a very easy question. It's just this language will make you fool. That's it. Language would play smart. So what do you need to do? I'll tell you. So what question says, try to understand. The question says, it tells the number of ways of arranging the counters so that the arrangements are symmetrical. So that means what? It is just, you have to just make the arrangement of one side. Do not need to worry about the other side. Why? Because the other side will copy it. But other side will copy. In that case, what? Just focus on one side. So now tell me, in how many ways you can arrange this m plus n objects? We'll say obviously m plus n factorial upon same objects are there, m objects are same n objects are there. This is the total number of arrangement. That's it. Done. And this looks like what? This looks like as if it is what? M C n, or sorry, m plus n C n, or you can say m plus n C m also. Both ways. So which option do we have? A option. A option is correct. It's a very easy question. It is just the language is smart. I hope you guys have understood this question. If you have understood it, just give me a thumbs up. Okay. Let's move to our next question then. This is our next question. Question is, we have to find the number of ways in which 22 books can be given to 5 students. So how many books are there? 22 books can be given to 5 students, so that 2 students get 5 books each. 2 students, they get 5 books each. And the remaining students get 4 books each. The remaining third one, fourth one, and fifth get 4 books each. Summation will become what? 5, 5, 4, 4. It will become what? 22. Cool. So let's figure out in how many ways you can distribute. So try to understand the question. See, these are the books. Books can't be alike, right? They're different books. Now tell me first, in how many ways you can divide these 22 books? Divide 22 books in 5, 5, 4, 4 groups. We'll say 22 factorial divided by 5 factorial, 5 factorial, 4 factorial, 4 factorial, 4 factorial. But since equal groups are there, for these 2 equal groups, I'll have to introduce 2 factorial. For these 3 equal groups, I have to introduce what? 3 factorial. So these are the total number of divisions. Now it is about distribution. You have to distribute. It says distribution there. Can be given. Given means distributed. You have to multiply with what? Once you make the groups, you have to distribute this to 5 students. You have to multiply with what? 5 factorial. The final answer would be this. Okay. So it's a very simple question. I hope everyone must have understood this question. Okay. Let's move ahead then. Let's read the question. What question says? Question says, in how many ways can 10 different prizes be given 5 students? One particular boy must get 4 prizes. So one particular, see it says what? One particular. So that means this guy is fixed. He gets 4 prizes, and rest of the students can get any number of prizes. So rest of the students, so remaining, we have got how many students? So that's S1. So we have got S2, S3, 4, and they can get any number of prizes. There is no limitation on that. So tell me, how would you solve this? Tell me, how would you solve this? Right? Very easy. So what you need to do is 10 different prizes be given to 5 students. One particular boy must get 4 prizes. Rest of the students can get any number of prizes. Basically, if I want to divide, so what I'll do is first I pick, let's say, 4 prizes. So in how many ways can I pick 4 prizes? Like this. So I chose 4 prizes. Fine. So let's say these 4 prizes will go to, out of these 4 people, out of these 5 people can go to anyone. Fine. So this is the total number of ways of distributing 4 prizes. Now this will get multiplied to what? This will get multiplied to, now I have got 6 prizes are left, and I can give any number of prizes to these 4 students. The rest of the students can get any number of prizes, right? So now these, so the remaining prize, so remaining 6. So remaining 6 will have, first it will have 4 options, again it will have 4 options. So I have what? 4:6. So this will be the total number of ways you can distribute 10 different prizes to 5 students, where one student is going to get 4 prizes. Here, first you chose 4 prizes. First you pick those 4 prizes. Then you gave that 4 prizes to one guy. So out of 5 guys, you chose one, picked one. Now for the remaining 6 guys, you had 4 options. So you did 4:6. I hope this is clear with everyone. Here, let's move to the next question. What does this question says? Question says there are n different toys. N different toys are there, have to be distributed among n children. So there are n children also. Find the number of ways in which these toys can be distributed so that exactly one child gets no toy. Exactly one child gets no toy. That means other people are getting toys. So n minus 1. So if n minus 1 are getting toys, so that means everyone is having what? 1, 1, 1. Right? Everyone is having 1, 1, 1, 1, 1. Here, when they are having 1, 1, 1, 1, and only one guy is not having 0, so that means the last one will have to what? Here. So if you just look at this, you can clearly see you have what? You have what? N minus 2 kids. They are having one object, then one is not having anything, and the last one is having what? 2 objects. Clear? So let's see in how many ways we can divide first. So we have what? N factorial upon, we have got what? 1 factorial, 1 factorial. How many times? N minus 2 times. For that, I'll have to introduce what? N minus 2 factorial, because same groups are there. Then for the last one I have to what? 2 factorial, right? Because these are the groups I'm making. 1, 1, 1, 1, 1, 1 groups, and 2 last. Okay. So 1, 1, 1, n minus 2, and this will be what? This will be raised to 1 factorial, 1 factorial. It will be what? If you just look at this, it is basically n minus 1, n minus 2 times. Here, so this is for the, and for distribution, now you are distributing this where? Now you are distributing this among n kids, n children. You have to multiply with what? N factorial. That's it. Question is sorted. I hope you guys have understood this question also. So basically, first I made the groups. In groups, I made 2, 1, 1, 1, 1, 1 like this. So n minus 2 student, 2 groups were there. For that, I have to introduce n minus 2 factorial because it's the same. Same groups are there. So we have these groups are same. So I told you, if you remember, for the same group, I have to introduce same number factorial. Here. Shall we move to the next question then? Okay, let's move to the next question. The question says, find the number of non-negative integral solution of the equation x plus y plus z plus 2w is equal. Tell me, how would you like to solve this question? Okay guys, so as I told you, if you remember the application, I told you that every variable should have the same weightage. So as we can see, the same weightage is not there, so we have to convert this into the same weightage. So how can we do that? We have to make specific cases. How? So one case, what we can do is we can assign some values to w. Let's say if w is what? Let's say 1. W is 1. X plus y plus z will become what? 18. Yes. So now how can we do it? What we can do is we can, let's say, have how many horizontal bars? 18 horizontal bars, and we have to distribute these horizontal bars in 3 parts. So we'll introduce only 2 bars here. Wherever whatever on the left of the bar comes, it will go to the x, then this between part will go to the y, and the rightmost part will go to the z. Cool. So these many solutions will be there. So now tell me, see here I can see how many bars are there? 18 bars, 18 horizontal, vertical 2 bars, 2 vertical bars. Total objects 20 objects. Here how many objects are there? 20 objects. 20 objects and divided by what? 2. Why divided by 2? Because what you can do is, if you don't feel like doing like this, 20 factorial divided by 18 factorial, because 18 horizontal bars are there and 2 vertical bars. Here similarly you can take for other case when w is 2. In that case your equation will become what? X plus y plus z is equal to what? 16. So how can you solve this? You'll have what? 16. But you'll have 16 horizontal bars and 2 vertical bars. It will become what? 18 C2. Right? Similarly for W3 you will write what? It will become 14, then it will become 16 C2. W is equal to 4, then it will become what? 14 C2. W is equal to 5, become what? 12 C2. W is equal to what? 6, become 10 C2. W is equal to what? 7, it will become what? 8 C2. Yes, 7, then it will have 14, then 6 and 2. It will have 8, it will become what? Become what? 6 C2. And it says non-negative. Non-negative means 0 can be value, 0 can be the solution. And it has W is equal to 9. So it has what? So this will have 18 over here. It will become what? Plus x plus y plus z is equal to 2. Non-negative solution can be possible, right? We'll have 4C2. We have 2 horizontal bars and 2 vertical bars. We'll just arrange them. Here, now tell me one thing. If I put w is equal to 10, we'll have what? X plus y plus z is equal. There is no horizontal bar. There is no horizontal bar. And there is no horizontal bar. That means x plus y plus z will be what? All three will be equal to 0. This will be also one of the solution. In that case, what will happen? If w is equal to 10, would say what? 2c2, or you can directly write 1. So now you can just add them up. So when you try to add them up, so what do you see? You get 20c2 plus 15c2. You continue till 2c. You can find out the values and you can find out the answer. Or if someone knows binomial theorem, then he can play very smart and he can find out the answer also. You guys, I hope you guys have understood the solution. Can we move to our next question? Cool. Let's move to our next question. This is our next question. The question says, find the number of non-negative integral solutions of the equation. Question is what? X plus y plus z plus w lesser than 20. Lesser than 20. It says what? Non-negative. So to remove the inequality, what I can do? I can introduce one more variable. Let's say t. And this t will be what? It will be what? Greater than 0. You can take any value. Now it's easy. So basically you have 20 horizontal bars. You have to introduce what? 4 vertical bars. Basically 24 objects, and same objects you have 20 and you have 4 vertical bars. Basically this will be your total number of integral solutions. That's it. Good. Very easy question. Now let's move to our next question. Question says, in how many ways can a party of 6 men be selected out of 10 Hindus? So there is a party of 6 men that can be selected from 10 Hindus, 8 Muslims and 6 Christians. If party consists of at least one person of each religion. Okay. So basically party has one person from each religion at least. That means out of 3 people, 3 has one Hindu, one Mohammedan, one Muslim and one Christian, and remaining 3 can have any number of Muslim, Christian, or number of Hindu, Muslim or Christian. Then we have to find the number of ways of selection. We have to make the selection. So what we'll do is, first let's say pick these 3. So how can I pick these 3? So if I want to pick 3, so what I'll do is, so I want to pick one Hindu out of 10 Hindus. So I'll say 10C1, then I'll have 8C1. See, all these people are different. See, these are people. People will be different. They can't be alike. 6C1. This is this. Now, remaining how many people are left? So 10, 8, 6. So we have 24. 24 minus 3. So 21. 21 are left. So out of 21, we can pick any 3. 21C3. This will be the total number of ways of selecting. Okay. Now, if let's say twist the question a bit. How can I twist the question? So all these things will multiply. So the final answer will be what? 10 into 8 into 6 21C3. Your answer. If I want to twist the question, so how can I twist it? I can twist the question like this. Now consider only religion of the person. So what it means is religion of the person. So basically I am assuming same people, as in they are alike. There is no difference because The only thing we need to consider is only the religion. If that is the case, we are having same people, same. So tell me, how can I pick? Tell me, how can I pick? Same Hindus are there, same Muslims are there. So what I'll do is, so obviously if same Hindu, same these things are there, so I'll fill, let's say, I have, just see the question. So since same Hindu, same Muslim, so obviously one way. So choosing one Hindu, one way, choosing one Muslim, one way, choosing one Christian, one way. In two. Now the thing is, in how many ways I choose three people? Choosing remaining three. Choosing remaining three. Basically these three, so if you consider these three can be what? They can be written like, let's say, Hindu plus Muslim, any number of Hindu, any number of Muslim plus any number of Christian will be equal to what? 3. Basically we have to just find out the solution for this equation. Now this is again non-negative. This can't be, Hindu, number of Hindus can't be negative. Hindus or number of Muslims can't be negative. Correct? So basically we have to just find the solution for this linear equation. So we have what? 3 horizontal bars, 2 vertical lines. So basically we have 5 objects. Out of these 3 objects are same, 2 are same. So if you solve this, how many ways you get? 10 ways. Choosing remaining 3. So how many ways are there for this? 1 into 1 into 1 into 10 ways. The final answer will be what? 10. Okay. So this will be the solution for this question. I hope you guys have understood this question. I know today's session was really long and we have a lot of concepts, like now we have multinomial theorem, we also have inclusion exclusion, we also have rearrangements. So these are the things I'll also there for to be studied. So what we can do is we can just study those things tomorrow. But before that, this is the last question for today. What is the question? The question says, find the total number of positive integral solutions for x, y, z. X, y, z, basically we have to find this set of x, y, z such that x, y, z should be equal to what? 24. Now you would say, how can I solve this? I'll tell you the way. What you can do is, this 24, let's write it in terms of factors. So this will be what? 2 raised to 8 into 3. 2 raised to 3 into 3, correct? Now just think. This 2 has got some power. So 2's are alike, right? So 2 can go to x. So some power of 2 can go to x. Some power of, if you just look at this, so what it is, see, every x, y, z is what? Every x, y, z is what? It is like this. 2 of x1 into 3, like this. 2 of x1 into 2 of x2 and 2 of x3 and into 3 is equal to what? 2 raised to 3 into 3, like this. So if you just see what it is like 2 raised to x1 plus x2 plus x3 into 3 is equal to what? 2 raised to 3 into 3. So if you just compare, what do you see? First you see this x1, the exponents of x, y, z. The exponent of 2 for x, y, z, this should be 3. So if you find out these number of ways, you'll say directly that, total number of ways will be what? 5 factorial upon 3 factorial into, directly say it is 10 first. Here. Now this 3 can either go to x, can go to y also, can go to z also, right? So these are basically the values of x1, x2, x3. Here. Now this 3 will have to be either with x, either with y or either with z. Basically, how many ways? How many ways for 3? Or you can say how many places for 3? For 3, 3 and 2. Now, in how many on how many places 2 can go? Go to 10 places. So what are the total number of solutions? Total number of pairs you can get? 30 pairs. Right? 30 sets actually. 30 sets of XYZ. Okay? So that's it. So this is for today. I think this is the last question. And oh, we have got one more question. So let's do one thing. Let's keep this question for the homework. Oh, we have got one more question. Let's keep this question also for homework. You guys can solve this question for homework. We can discuss this question tomorrow. And tomorrow we'll study multinomial theorem. We'll study all the cases, solve questions on. Now, I'm running a fun day series. So this fun day series is on install the application and follow me there, follow Nishant there, so that you will get notification. And this fun day series is specifically dedicated to learn fundamentals while solving questions. Okay? And we try to solve difficult questions using the basic fundamentals. So tomorrow I'm running a session, and that is a quiz. It's basically a quiz. This is their free special class. You guys can come tomorrow, and tomorrow morning 8. You guys can come and you can attend this special quiz. This quiz is there on probability. You guys can come tomorrow and you guys can solve first. So basically I'll be giving you 10 questions in the quiz. You can solve those questions, and later on we'll be discussing the solution for each and every question. Okay, fine. So if you have liked my video, I would request you guys to just like it, share it with your friends. You can subscribe the channel Let's Crack JEE in English, so that you will get all the notifications, all the details, whatever is there on this channel. You can hit the bell icon button, so whenever anyone comes online on this channel, you get notification. And you can use NK001 code if you have planned to use or plan to buy Plus or Iconic subscription. You can also join the Telegram group link, which is there in the description, so that you will get all the notifications there also. Okay, guys, so this is me and Nishant, and I would like to say goodbye today. Bye guys, we'll be seeing you tomorrow. Tomorrow we'll be solving, and tomorrow we'll be learning more. Be ready guys. Tomorrow we are going to have one more good sessions, and we'll be solving multiple questions. Guys, signing off. Bye bye. Take care.